pre-launch procedure of the powerful Energija multipurpose launch vehicle is in progress. The launch vehicle is intended to put into near-Earth orbits large-scale spacecraft for scientific and national economic purposes and reusable orbital vehicles. The development of the Energija launch vehicle was preceded by sustained efforts by the design and manufacturing teams. This event has been waited for several years, and here is the start. Energija liftoff. To provide for the vehicle launches, a special launching complex has been constructed on the vast territory of the Baikonur Cosmodrome. The launch pad from which the launch vehicle is lifted is a reinforced concrete structure with umbilicals and communication means for controlling, processing, fueling, and launching the vehicle. Special storages are built at a safe distance. Propellant components and gases from these storages are transferred along pipelines to the propellant tanks. The servicing of the launch vehicle and launch pad equipment is performed from a mobile multi-story tower. Due to extendable platforms, it surrounds the rocket on all sides and provides access practically to any of its units. In the course of the launch, the exhaust gases are discharged through a one-way duct. The Energija launch vehicle consists of two stages. The core module serves as the second stage. Full strap-on boosters are attached to the core module to form the first stage. The launching docking complex is used for assembling and docking the rocket with the launch pad. The payload to be put into orbit is mounted on the side of the launch vehicle. The core module of the rocket consists of a tank with an oxidizer filled with liquid oxygen. An inter-tank compartment with a control system instrumentation. A fuel tank for liquid hydrogen and a tail compartment containing engines. The core module has about 8 meters in diameter and 59 meters in length. The use of liquid hydrogen as a rocket propellant required the solution of a number of technical problems. The low specific density of hydrogen has determined the large size of the fuel tank. Because of the small wall thickness of the tanks, they were assembled in vertical position. Many materials change their physical and mechanical properties in a liquid hydrogen environment. Therefore, new special materials were produced and studied. Technological processes for the manufacture of large-scale and other components of the launch vehicle were developed, and a modern production base was created. A great amount of experimental work was carried out to introduce various types of welding to provide welds of high strength and density. The creation of the launch vehicle required the solution of other important tasks as well. Specifically, a perfect control system for the rocket was developed. The first stage booster has 4 meters in diameter and 40 meters in length. The boosters run on oxygen and kerosene. Each booster of the first stage of the launch vehicle contains reusable full-chamber rocket engines RD-170 with a thrust of about 800 tons. The core module houses 4 liquid rocket engines, each with a thrust of about 200 tons. For an experimental testing of the engines of the first and second stages of the Energija launch vehicle, a bench base was created where separate systems and units, as well as completely assembled engines, were tested. Finally, the functioning of the first stage propulsion unit was checked up in the course of complex bench tests and in flight on the first stages of the launch vehicle. The launching docking complex serves for power and functional linkage of the rocket modules of the first and second stages. Mechanical linkage, electrical and pneumo-hydraulic bonding of the launch vehicle with launch pad and ground support equipment are performed through this complex. Large-scale units of the rocket modules were delivered to the cosmodrome by special aircraft. Autonomously tested rocket modules were assembled into a launch vehicle pack in the assembling testing building and then subjected to checkout tests. The test program was read into a digital computer, on the base of which electro-testing equipment was created. To estimate the correctness of technical solutions on the launch vehicle structure, several experimental prototypes were used for its development. The development work included a fitting of the launch vehicle on the launch pad and defining its dynamic characteristics. Optimizing the fueling technology, and hot firing of the core module. The launch vehicle dynamic characteristics were determined on a special technological prototype, which included a force driving device instead of one of the engines. This launch vehicle prototype was delivered to and mounted on the launch pad by the transporter erector. The launch vehicle vibrations were excited by static force effects on different points of the core module, followed by their abrupt stopping. The vibrations excited were measured through telemetry channels. Operations on the fitting and docking of the launch vehicle and launching complex were performed using another prototype, a dummy technological one. Liquid hydrogen loading into the launch vehicle requires special preparation. Initially, the pipelines and tanks are purged with nitrogen and then with gaseous hydrogen, and only then is the tank filled with liquid hydrogen and liquid oxygen. At the engine starting and cutting off during the launch and bench tests, the hydrogen excess is burnt out by the reheat system. Multiple tests of this system confirm the reliability of its functioning, including in conditions of water cooling of the launch pan duct. The most crucial phase has come, the hot bench tests of the core module. The loading operations are completely automated. The readiness of all the systems for starting is being monitored. The first hot test lasts for 20 seconds. It should confirm a number of key solutions and operations providing operation safety. Here is the engine start. Suddenly the firing was stopped. The engine emergency protection system had worked. In the case of a malfunction, it should provide a non-emergency cutoff of the module propulsion unit and bring the rocket into a safe state in accordance with the nested algorithm. On defueling, the launch vehicle was inspected. The faults revealed during the first hot test were corrected. Preparations for the second hot test have begun. The T10-minute readiness is announced. Direct preparation of the vehicle launch has begun. Complex checkout of interaction and serviceability of all the systems of the rocket module is being carried out, including engine turning for thrust vector control. Along with other advantages, powerful oxygen or hydrogen engines first installed in a launch vehicle of this class have one more important feature. Ecologically pure combustion products, mostly water vapor, are ejected into the atmosphere. The engines have worked out designated time. The tasks of the bench testing of the second stage of the launch vehicle have been achieved. The ground experimental development of the Energija launch vehicle has been completed. A procedure for the first flight test of the launch vehicle is being developed at the Baikonur Cosmodrome. The Energija launch vehicle makes it possible to put into a near-Earth orbit a payload of more than 100 tons. It can be an orbital station, an interplanetary spacecraft, or a set of satellites. On completing the pre-launch procedure, the launch vehicle is loaded with the fueling components. May 15, 1987. Commands for the engine start and attainment of nominal rating conditions are being sent through. To lift off the launch vehicle from the launching pad, it is necessary for the engine thrust level to exceed the rocket mass of 2,400 tons. The lift-off contact command has run. The transfer module and the umbilical vent mass area are being jettisoned. It is now 21 hours, 30 minutes Moscow time. The launch vehicle is in autonomous flight. The launch vehicle systems function normally, showing parameters near to designated ones. A successful start of structural and flight tests of the Energija rocket space complex opens a new phase in the development of cosmonautics and serves as a good base for the realization of international projects of space exploration.